Hello and welcome back to Technology Now, a weekly show from Hewlett Packard Enterprise where we take what's happening in the world and explore how it's changing the way organizations are using technology. We're your hosts, Michael Bird
and Aubrey Lovell. And this week we are delving into the fascinating world of the digital twin.
Ooh.
We'll be asking the obvious question, what is it? We'll be looking into how digital twins are made and the technology needed to do so. And we'll be answering the question, why would someone want one of these in the first place?
Yes, that is right. So if you are the kind of person who needs to know why what's going on in the world matters to your organization, then this podcast is for you. And if you haven't yet done so, do make sure you subscribe on your podcast app of choice so you don't miss out. All right, Aubrey, let's get into it.
Let's do it.
Right, so Aubrey, I'm going to put you on the spot here. How do you present data?
Well, there's obviously a lot more options these days. There's all different types of systems that we use and metrics that we track, but I'm curious, how do you present data?
I sort of organize my life in spreadsheets with the occasional graph.
Beautiful.
Anyway, I think for many organizations, it's a big question, and it is an incredibly important one to answer. And it's all well and good to have a big table full of numbers, don't I know? And maybe it's showing readouts from machines or sensors, but it is really difficult to visualize what these can mean in practice when you're overwhelmed by the quantity of data in front of you. Now, one way of showcasing this data is using models. These can be models on a screen or even 3D models using virtual and mixed reality to help somebody understand what the data in front of them is actually saying.
But if you want to demonstrate how something works, think about a factory floor or an aircraft. You need that model or twin to match the object in real life exactly. But to make the model identical to real life, you need the data, and lots of it. If you want your model to be changing in real time to reflect a factory floor, you need not just the infrastructure to measure what's going on, but also to process the data and present it in a digestible way. So how do you go about building and using one of these twins? Well, while he was at Hannover Messe, Michael spoke to Sebastian Schwarz, general manager at NetAllied, to find out more about these digital and 3D twins.
So my understanding of digital twins is that they aren't very visual. They tend to be more on paper, but it's the sort of stuff that you're creating like 3D versions of digital twins.
A digital twin itself has nothing to do with 3D. Effectively, the foundation of each and every digital twin is data. Without data, you're lost. If you want to build something like a digital twin, and digital twin is quite a complex term. So what we have typically before we have digital twins is we have digital shadows. And before we have a digital shadow, we have a digital representation of something. And all of that has nothing to do with 3D. So the solution really is having a representation, a digital representation of your asset, a product, a factory, whatever, then have it as a digital shadow that is reflecting really what is happening outside there. As always, 3D has nothing to do with it. It is just an additional layer on top of that, an additional attribute to your assets, but it's quite valuable. And if you want to take a look what your factory might look in the future, a 3D digital twin might be an interesting thing.
So you're creating essentially a digital version of a physical object, a building, a space, on top of sort of a digital twin as it is. That sounds pretty sci-fi.
Yes, sounds sci-fi. It's not so much sci-fi for us. We're doing exactly the same thing. It was claimed differently the past 20 years ago, but it is somehow sci-fi. Let's see it like that. Why? Because if you really want to have a living, good and great and working digital twin, it involves so much work. You have digitalization strategy, you have high quality of your data. You need to address your data, you need to align your data, you have a consistent data flow. So it's quite useless to have a digital twin that you build up once and that is not living. So if you change something in your production pipeline, for example, you really need to make sure that your digital twin is living. And then on top, yes, sure, that 3D component is something that you see from film industry. And so there is a bridge between that sci-fi videos and sci-fi films and a digital twin somehow from a technical point of view, yes.
Okay, so what is the purpose of a 3D version, a 3D visualization of a digital twin? Because presumably you have all the data, you can understand what's going on.
So in contrast to the typical digital twin, where you only know the feedback from your sensors, is that additional layer includes better optimization. For example, if you have the 3D model attached to your digital twin, you can do collision detection, you can have clearance, you can have something like optimizing the paths that your workers are taking, better logistics, just due to the fact that you have with this additional layer of complexity, but also on information, the 3D layer, you can start training your people far beyond the product has been manufactured.
I guess we as humans are quite visual people, and I think
Yes.
visualizations is quite helpful to picture a factory floor or a product line. You can sort of go, oh, we do that, and then we do that. Oh, that makes sense.
I'm coming from the engineering perspective. Our digital twins do not really look that fancy. Why? Because it's engineering data being visualized. So it happens that the building itself is green and the floor is red and the steel is yellow. And the engineers plan it like that because they want to have a quick visual representation. This is one aspect of the 3D digital twin. And the other one really is then, if I have the materials, if I have textures, stuff like that, then I can prepare great renderings. I can, even for people that are not yet into that engineering business, can present the details. What will your factory look like in the near future?
So what is the process of building a 3D twin? Is it a lot of fancy 3D cameras, LiDAR sensors, that sort of thing?
I know everybody's claiming LiDAR scans as a digital twin. The problem is, this is only the last step that you ever should do. If you're in LiDAR scans, you did something wrong in the beginning. It all depends on the data, the quality of the data, the confidence that you have in your data, the actuality of the data, stuff like that. And all of that is killed if you're taking a LiDAR scan, because a LiDAR scan, you take that picture, it takes, let's say, an hour to scan your factory, and then you get it out of your factory, and then it looks the next day completely different. It is a good approach to start. If you have nothing, if your factory is 100 years old, well, it might be that you do not have 3D data for your digital twin. But effectively, you should keep your data clean. You should keep consistent with the data. If you modify something like a conveyor, a moved robot, something like that, then please keep in mind to update your planning systems, to update your building information management systems, stuff like that. If you do it correctly, you will hopefully never again have to do a second LiDAR scan again.
So you're saying good data in, good data out. Rather than doing a 3D LiDAR scan, you're taking existing data from those organizations.
Yes, exactly. You need to be as close as possible with the engineers, with the designers. So you have that digital representation, you have that digital shadow that is coupled with the real data, you have the digital twin that is feeding the information back. But all of that depends on a consistent data flow from the very beginning, from your engineering phase, up to then the 3D digital twin.
Thank you, Sebastian. It really is unbelievably sci-fi, and I kind of have this vision in my head straight out of a film, right, with the floating models in front of me. Really looking forward to finding out more later in the episode.
Okay, well, now it is time for Today I Learned, the part of the show where we take a look at something happening in the world that we think you should know about. Aubrey, what have you got for us today?
Alrighty then, Michael. A couple of weeks ago, you did a Today I Learned all about the breaking news of a new dinosaur.
Yes, I did.
Well, if you thought that a new dinosaur was a surprise, then I've got an even bigger one for you. Are you ready for it?
I'm ready. What is it? What is it? What is it?
Okay. Scientists claim to have discovered a new color.
No.
Can you believe it? How do you even do that? I mean, now I'm kind of triggered because with the whole planet situation, it's like, oh, this is a planet. No, it's not. Yes, it is. And now we have a new color.
Go on. Explain this new color thing.
Well, this new apparent color named Aloe was seen by 5 people after scientists in California fired lasers into their eyes to manipulate their retinas. This is getting a little crazy, guys. Okay. The color itself cannot be printed or shown on a screen, but was described in the paper announcing its discovery as a blue-green of unprecedented saturation.
Okay.
Interesting.
And it can't be printed or shown on screen, but our producer has put an approximation in front of us, Aubrey.
It's definitely giving teal or like a seafoam green if you're into interior color design.
Yes, I think seafoam green or teal is how I would describe it.
Now I'm even more perplexed because how can you even consider it a color if you have to fire a laser into your eyeball?
Feels like a very exclusive colour.
Definitely. And I've assumed that you've heard of rods and cones in the eye, right, Michael?
I have heard of rods and cones.
These are the cells in the eye which detect light. And in this case, cones are the ones we care about as they are responsible for our color vision. So we have kind of 3 different types of cones which respond to short, medium, and long wavelengths of light. And in real life, there is no color which activates the medium type cones without either the long or short cones. However, this study used lasers to bypass the long and short cones and excite the medium cones exclusively, hence probably the laser.
I see. I see. So it was triggering a part of the eye that isn't normally triggered or can't be triggered. I see. Okay.
That's correct. And obviously, as you can see where this is going, the work has had mixed responses within the scientific community. However, the researchers hope that it will help us understand more about color blindness or even how the brain creates our visual perception of the world from the information it gets from our eyes. Huh.
I think that I can imagine the conversation of those scientists asking test participants or other scientists to take part in this experiment. You can imagine it was something like, so Dave, I've got something I'd like you to take part in. Yeah, what is it? Involves lasers. Okay, yeah, I'm keen. Keep talking. I'm going to shine them in your eyes. Okay, I'm out. You can find somebody else.
Can you imagine the paperwork that you needed to sign to get that rolling? Goodness gracious. All right, well, let's return to Michael's interview with Sebastian Schwarz, recorded at Hannover Messe.
I feel like we've got slightly ahead of ourselves because what I haven't actually asked you is about who are you building these models for?
Our customers include the biggest aircraft manufacturing companies. And what they have is they're not so much interested in the factory. They're more interested in the product. The product in this case is the aircraft. And each aircraft is a complete different one from the previous aircraft. So they are really highly individualized for the specific airlines, for example, and they need a digital twin. And the data here is enormous. So we specialized on handling these huge amounts of data.
And from a data perspective, in terms of the sheer amount of data required to build a 3D visualization to begin with, this is not something that's static. You're continually feeding data into it.
Just some rough numbers to give you an idea. A final assembly plant of an automotive manufacturer. This is where they are out of the paint shop and now they are integrating the different stuffs. There are so many jobs for one specific vehicle that can be customized. And you have 100,000 tasks. You have 80 million different nodes. So it's the leaves of your digital twin. One leaf would be one single screw. One single screw in one station in one vehicle. This is one element. We have 80 million out of that. So we just provide the technical infrastructure to handle even that 1% 3D digital twin use cases.
And you're continuously feeding data using sensors on the floor, sensors in the factory, or sensors on the aircraft. When we say sensors, what do we really mean by that?
Well, a sensor effectively is something that is giving me data from real-time infrastructure. A sensor itself can be actively measuring the distance of a gripper to the body in white in automotive production. A sensor can identify what is the current position of my robot. Everything that is giving us data, real-time data, and they need to be accumulated and handled in a fancy way that makes sense. And they're very important not to forget is if you want to use your digital twin data throughout the whole production pipeline and then feed stuff back again to the beginning, to the engineers, to the designers, you really need to take care about not only having the data available, but also make it uniquely identifiable. It is a complex task. And it's an ongoing task. So it's something probably nobody wants to hear because it's so boring. But from my perspective, it's not boring. It's digitalization.
So what are some of the big challenges? I mean, we sort of alluded to one, but what are some of the big challenges that come with creating a 3D twin of, say, a factory?
Several of that problems have already been mentioned. The amount of data, the actuality of data, the confidence that we have in the data, the effort it takes to migrate the next iteration of my digital twin, to keep it consistent with the reality, all of that. It requires often that you have, a top-down approach where really different silos and different departments are working closely together, and be aware of there is something before me. I am consuming my engineer's data. I'm doing the simulation, and now somebody is doing something with my simulation. I want to provide consistent access to the data and access that is easy to be reused for non-specialists that follow my specific domain.
So what's the future for 3D digital twins? More VR, AR, better renderings?
So the more we have a 3D digital twin, and the more people see the benefits of the 3D digital twin, they communicate to their predecessors, please raise the quality. Please help me to get better data from you. And I will provide better data again to you. So we have that closed loop where I'm generating data for my predecessors and my successors. And this is a natural way that 3D digital twins will evolve and will get better with each and every iteration. Obviously, it will be the foundation for good and trustworthy AI agents training. And so, future is bright for 3D digital twins.
All right. Thank you so much, Sebastian. And it does feel like a big step into the future using these 3D twins. And I'm kind of disappointed that I've never had the chance to use one myself. Okay, well, we're getting towards the end of the show, which means it's time for This Week in History, a look at monumental events in the world of business and technology, which has changed our lives. Okay, Michael, you gave us the clue last week.
Yes, I did. Yeah, last week's clue was it's 1840 and this little picture of the Queen is going to take you places. Aubrey, any idea what you think this is?
I can't remember what my response was, but hearing it back, I was thinking maybe it's some sort of ship, but I don't think that's correct.
Well, I knew it because I'm a bit of a nerd. I think I said stamps. And it is, of course, the release of the first adhesive postage stamp called the penny black. Now, these days we have email and people do use the postal service much less than they used to. However, back in the 1800s, the idea of weight-based prepaid postage was completely novel. The first design was rejected and ridiculed into submission. However, the second design, which was based on a sketch of Queen Victoria, went down much better. This version of the then Queen would stay on the stamps for the remaining years of her 63-year reign. The stamp allowed letters of up to half an ounce, we'd call that 14 grams here in the UK now, to be delivered for 1 penny regardless of the distance. Now, within the first year of what became known as the penny post, the number of letters sent had more than doubled, with the number doubling again within the decade. Now, obviously, with the advent of email, we send far fewer letters nowadays. Imagine if the 100 emails that the average worker got a day came as letters. However, I think I would say that the penny black is probably one of the most important inventions in history. Aubrey, have you sent a letter recently?
I actually have, believe it or not. Yeah, I still believe in it. My handwriting is not so great, but I think still sending letters is wonderful. It's a wonderful thing to have, for sure.
My young nephew and I became pen pals briefly when he discovered that he could send letters.
Aw.
So I got a lot of enjoyment out of sending letters. Right, Aubrey, you've got next week's clue. What have you got for us?
Okay, so this one is a huge moment in history, and we're bumping it up a little bit. It's 1980, and this microscopic killer is gone for good.
Ooh. Okay, 1980s. Oh, goodness me. It's the eradication of something, isn't it?
Definitely.
Some vaccination program. Or what would that be? Something like measles? No, not measles. What would it be? Polio. I'm going to go polio. Maybe that's too late. Or I don't know. Okay. I think it's going to be I think it's going to be some sort of vaccination eradicating some sort of parasite, virus, bacterial thing. That's what I'm going to go with.
I think
What do you
that
reckon?
covers all bases, so I think we're going in the right direction for
In
sure.
the known, the unknown universe, across state and time. Yeah, that was too big of a catch-all. I should have been more
Very
specific.
diplomatic answer. I think we're going in the right direction.
Thank you.
And that brings us to the end of Technology Now for this week. Thank you to our guest, Sebastian, and of course, to you, our listeners. Thank you so much for joining us. If you've enjoyed this episode, make sure to leave us a review or a comment whenever you listen to our episodes.
Technology Now is hosted by Aubrey Lovell and myself, Michael Bird, and this episode was produced by Harry Lampert and Izzy Clark, with production support from Alicia Kempson-Taylor, Becky Bird, Alyssa Mitri, and Natasha Naik.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green, and our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett Packard Enterprise, and we'll see you at the same time, the same place next week. Cheers.